Welcome to the Data Science Career Guide course for interview preparation. This course is designed to help you prepare for data scientist interviews. I'm Jose Portilla and I will be your instructor for the course. I have over 300,000 students here on Udemy where I teach various topics, including Python, data science, R, web development, SQL, and much more. I also work as a corporate data science trainer for the world's largest companies. As you may have heard, data scientist has been ranked as the #1 job in the country by Glassdoor. This course is designed to be your passport for guiding you through the interview process for a data scientist. Let's start by giving you a quick overview of the curriculum so you can know what to expect. We'll begin with a general discussion of career options in the data science fields, answering common questions like what skills you should know, what various positions and titles are available, the differences between these positions, and whether or not having a graduate degree is important, as well as many more questions. Then we'll move on into a more detailed discussion on resumes, the interview pipeline, how to land interviews, negotiating offers, and more. Afterwards, we reach the heart of the course, practice data scientist interview questions and solutions in a wide variety of topics, including questions and answers on probability theory, machine learning, data manipulation with SQL, experimental design, coding questions, statistics, and product metrics and analysis. All of these are real interview questions sourced from recruiters working at some of Silicon Valley's top technology companies. This course comes with high-quality video, explanatory notes, and slides to help you prepare for your interviews in a way that works best for you. Not only do you get great technical content, but you'll also get access to our online question and answer forums, as well as access to our Gitter chat rooms to talk with fellow job seekers and other students. The course also comes with a certificate of completion for your LinkedIn account. This is all backed by a 30-day money-back guarantee, so you can take the course absolutely risk-free. So what are you waiting for? Check out the preview videos to get a better look at what is inside the course. Enroll today. Welcome everyone to the course. This is the course overview lecture. If you could do me a small favor, please don't skip this lecture. We're going to talk about a lot of really important things, especially the guidebook, which is a really fundamental part of this course, and it's going to help you a lot in your studies to become a data scientist. So let's get started. We're going to talk about quickly the course curriculum, where to get the resources, how to get help during the course, and the best approach for taking the course, as well as be walking you through the guidebook that goes along with this course. So first off, just very quickly what the course curriculum is. We'll discuss it in the very next lecture again, but basically there's a non-technical section talking about things like data science careers, positions and titles, what knowledge you're going to need. Then there's also non-technical stuff like how best to prepare your resume, what to expect during the interview process, how to negotiate offers, etc. So that's kind of like the first, I would say, third of the course. And then really the bulk of the course is the technical interview questions. So these are where you're given a technical interview question and then you're given an answer. So there's other topics like probability, statistics, machine learning, design of experiments, coding, product design and metrics, etc. So that's how the course is basically split up. You can feel free to jump around. It's pretty modular. So as I just mentioned, feel free to jump around in the sections. Course is designed to be modular, so you can approach it however you want. Some people prefer to do the technical stuff first and then jump to the non-technical. Some people like it the other way around. Really, it's totally up to you how you approach this course. It's designed to be as modular as possible. Now, the most important resource for you in this course is the guidebook that basically goes along with every single lecture in this course. So it basically has a bunch of really useful links that relate to every topic we discuss. So let's explore the guidebook. The guidebook is a resource link in this lecture. So as you're viewing this lecture, you should have seen some little pop-up saying there's resources for this lecture. If not, you can go to lecture number 3, frequently asked questions. There's another link, but it's basically a Google document with a lot of useful stuff. So let's go to that Google Doc and show you what the guidebook really is. All right, when you click on that link, you should see something that looks like this, basically the Data Science Career Interview Prep Guide. And if you scroll down, you'll eventually see a table of contents, and you'll also see the outline listed here on the left. Depending on what browser you're using, you may or may not see it, or you may accidentally click X, but don't worry, the table of contents is also right here. And basically what's really nice about this is that it has a bunch of fundamental resource links that we discuss during the lectures. So a lot of times during a lecture, you'll hear me say, check out the guidebook, check out the resources there, check out the links, and this is what I'm referring to. So let's imagine that you're on Data Science Positions and Titles lecture. You can come over here to Data Science Positions and Titles, click on it, and it will bring you down here to data science positions and titles. And here it has various links that are helpful, such as a large list of various job titles. And then in another lecture, we talk about higher education, whether it's necessary or not to have a master's degree or a graduate degree. There's other links there and other opinions on higher education, etc. So as you can see here, there's lots of useful links. When we get down to the actual technical interview preparation part, so for example, the very first section is on probability. If we go back down there to probability slides, you'll end up seeing that each of these technical sections has its own header. So we have probability theory resources. The very first link for each of these is going to be the slides. So if you click on this link, we'll go ahead and open this link in a new tab. So we'll go ahead and click on it. That'll open a new tab. But basically here we can see the probability theory interview questions. Now, the way we approach it in the video course, we're going to present one interview question, then a solution, then an interview question, then a solution. Sometimes people prefer to see all the interview questions at first and then go through the solutions. So if you prefer to see all the interview questions first, then what you can do is come over here to the slideshow, and you can see here there's interview question number 1, immediately followed by interview question number 2. As again, just a quick reminder, during the video course, once we show interview question number 1, we're going to immediately show the solution. If you prefer the method of seeing all the interview questions first, make sure you approach the slides, which kind of has it built like that. We tried to balance this out because some students like to see interview question solution, interview question solution. Other students like to just see all the questions first, then all the solutions. So depending on what style of learning you prefer, you have either the slides or the videos or both to help you out that way. So as you go down these slides, eventually, as you go through the interview questions, you'll see a slide here that says solutions. Solutions are up next. Solution for probability question number 1 to give you a fair enough warning that the solution slides are coming. And these slides, we go over them in the video. Now, let's say we're going through a solution on probability question number 1, and you want the resource links that go with that. So for example, probability question number 1, consecutive coin flip. There's little nicknames I've given every question. You can see here a bunch of useful links that are appropriate for that question in the probability section. In the course, in the videos, the lectures themselves are just titled simply question number 1, question number 2. If you go to the guidebook, you can see here there's a little bit of a description as far as what the questions pertain to. So for example, statistics question number 1, it had to do with something about raining in Seattle. So if you've gone through that question and you kind of remember that how to do something with raining in Seattle, you can come to the guidebook, search for Seattle, and you'll probably find what question we were talking about. Okay, so that's the guidebook. Really, really useful. We're going to be referencing it all the time during the course. So this is something that's basically going to be your study tool for the entire course. All right, now we discussed the guidebook. Let's quickly go up and finish our presentation. All right, we're back. We just explored the guidebook. Let's go ahead and finish off this lecture. So the next thing I want to cover is how to get help during the course. If you're ever facing any sort of technical issues or platform issues, things like the video is taking a long time to load, or you're having issues giving a comment or posting issues, just platform issues in general, please email support@udemy.com. I actually don't control the platform, so there's not much I'm going to be able to help you with there. But if you send an email to them or go to the support page and open up a ticket directly, the friendly folks at Udemy are going to be happy to help you out. Again, I can't really help you out with video buffering issues. Please email support@udemy.com and they're happy to help you there. If you have questions related to the course, this is the pathway I would recommend approaching to get the answer to your question as fast as possible. Honestly, I would just do a quick Google search first because a lot of other people have probably had the same question as you and posted it on some sort of Stack Overflow or Stack Exchange forum, and you can quickly find an answer that way. If you're still having trouble with whatever question, then I would suggest do a search in the guidebook. Check out the resource links there. A lot of them are made to kind of preemptively answer questions that may pop up. If you still haven't found the answer, do me a favor, do a quick search in the Q&A forums. A lot of people often have the same questions, so if you can do a search in the Q&A forums and talk to other students that have had the same question that may have already been previously answered by me. If you do all that and still there's no answer to your question, feel free to post to the Q&A forums and either I or the TA will be happy to help you out. As a quick note, we can't personally help you with current interviews due to some non-disclosure agreements that allowed us to actually create this course. You can feel free to post interview questions that you've been stuck on for other students to help collaborate on. But again, we personally cannot help you on your interviews. That goes against some agreements we've made. Some other quick notes, you can change the playback speed. So if we're going too slow for you or too fast, you can click on the little gearbox in the video. You can either slow it down or speed it up. And you can also change the video streaming quality. Also, if you want to download the videos, you can use the Udemy app to do that. And as I just mentioned, all slides are linked to in the guidebook. So really the guidebook has everything you need. Finally, I want to discuss the best way to approach the course. Really what this course is, it starts off non-technical, very brief overviews of how you can approach data science interviews and a data science career in general. And then really what the meat of the course is, it's a list of real example interview questions sourced from real companies and then the solutions to those questions. A lot of times the resources I've seen online, they just provide interview questions with no real solutions. So we try to actually add in solutions to these interview questions. Keep in mind, you're really going to need to do extensive self-study to prepare for any data science interview. The interview questions are real questions from Silicon Valley tech companies, companies like Google, Facebook, Airbnb, so you can expect them to be extremely challenging. These data science questions can be some of the hardest questions you've ever faced in an interview setting, and to be honest, if I just went in cold on a lot of these questions without having studied beforehand, I probably would not do that well, and I do data science all the time. So really expect these questions to be really challenging, and you're going to need to really prep a lot for your data science interviews. So if you're facing these questions and you find them really, really hard, don't worry, that's totally normal. And finally, a huge thank you for enrolling in this course, and I'll let you get to it. I'll see you at the next lecture. By now, you may have realized that the position title of data scientist is not the only title that pertains to data science ideas such as probability, coding, machine learning, etc. Let's go ahead and go over different positions and titles and what employers in general expect from someone applying to that particular position. So as I mentioned, data scientist is not the only job title that companies use, and lots of companies use different titles for different focuses for roles in the field of data science. And I should be clear here that companies also use the same term differently. So a data scientist at a small company may be called a data analyst at a larger company like Google. So we're going to go over a few titles and their general descriptions and things that tend to differentiate these titles. Again, each company may be a different situation. So first off, we have someone that's maybe called a product analyst or sometimes a product data scientist. And this is a person who analyzes user data to create reports that generally go to their product managers directly. And typically they're using coding as their main tool, but sometimes certain companies may prefer a predefined software tool, something like Tableau, for instance. Then there's the business analyst, or someone who works in business intelligence. And that's attempting to create insights and analysis from business data. So this may also be user data, but specifically this data pertains to whatever the main business of this company is. And often a business analyst or business intelligence engineer is going to focus on using a specific tool such as Tableau or Excel, or maybe using some internal tool. And in fact, if you're a business intelligence engineer, your job may be to actually help develop an internal tool that mimics some of the features of Tableau or Excel, but is more specifically designed towards whatever this particular company's business data is. Then you have the title machine learning engineer. Now, machine learning engineer, this tends to be a very technical role, both in theoretical knowledge and really good coding skills are necessary. And in general, the machine learning engineer is going to create custom machine learning algorithm models for the team. So they're not just going to do simple imports from some sort of predetermined library like scikit-learn or some of the models that already exist in R. If you're being hired on as a machine learning engineer, it's likely that you're going to have to develop some sort of custom machine learning algorithm model. And it's going to be based on the fundamentals, things like random forest or maybe regression models, etc. But you're going to have to customize them to this particular company's needs. So again, this is usually a very technical role, and a lot of times companies are going to demand some sort of higher education to reflect that technical ability. Not always, but it is pretty common. Then you have a data engineer role, which differs from the machine learning engineer. Now, a data engineer, it's again a technical role, but it's actually focused more on coding and tools and not so much on theory. And a data engineer typically at a company is going to be building pipelines that connect the actual data warehouse to data analysis or machine learning systems. So a lot of times you can think of the data engineer as the person that's building the systems that connect the actual data warehouse to the team that's going to analyze it, the data scientists themselves. Then you have this classic data scientist role and title, and this generally requires a mix of coding and theory skills. And often companies are going to post a more detailed use case on the actual job posting. So overall, for many of these positions, focus less on the actual title and focus more on the qualifying skills of the job posting itself. So you can use sites like glassdoor.com to find out more information about company job titles and what that job title actually relates to as far as day-to-day tasks are concerned at that company. Thanks, and I'll see you at the next lecture. Welcome back, everyone. Before we end this section, I just want to give some thoughts on higher education, things like a graduate degree, such as a master's or a PhD, and how that may help in your job search and what that really means for your job search as a data scientist. So this is a really common question that I get from students a lot. Do I need to get a master's or a PhD to pursue data science? And a lot of what is about to follow, it's really just my personal opinions, and you're going to need to take the time to reflect on your specific situation and maybe the specific company that you're applying to. So take that into consideration as you listen to what I have to say. In my personal opinion, it's going to be harder to get a job in a position with formal requirements like machine learning engineer without an advanced degree in a larger company. And often, recruiters at these larger companies like Facebook or Google, they're going to be given requirements for candidates to actually have either a master's or a PhD, and they're just not going to be really allowed to consider you if you don't have those graduate degrees, unless you've done something absolutely phenomenal, like you've created your own deep learning library that has a lot of users. Now, if you plan to go more of an entrepreneurial route, such as freelancing, graduate degrees become less important. At that point, it really matters what you've done and your portfolio of projects that you can show for it. So no one's really going to care if you have a PhD, if you're just freelancing and you've already have a portfolio of satisfied customers and different projects you can show off. Now, keep in mind, each individual situation is different. Many entrepreneurs come from graduate degree backgrounds, and some employees at large companies that do work as machine learning engineers, for example, don't actually have graduate degrees. So it's a spectrum. There's definitely different cases for each situation. So I want to take a look at just two extremes on this spectrum of higher education so you can get an idea of what's actually in the real world out there. Now keep in mind, most people are going to be somewhere in between these two real life examples. I'm going to give examples of two people kind of on the extremes of the spectrum, but again, most people are going to be somewhere in between. Okay, so let's first look at Ian Goodfellow. I would say he's on the extreme spectrum of getting higher education. So he has a bachelor's and master's in computer science from Stanford University, and then continued on to get a PhD in machine learning. He's a co-author on a book on deep learning. And more importantly, he's one of the creators of generative adversarial networks, which is a very popular and very trending type of neural network in the deep learning space that allows you to basically generate examples of data. Now, Ian Goodfellow here, he used to work at Google, then he moved on to OpenAI, and I believe now he's actually back at Google. As you can imagine, someone of his skill set and his technical knowledge is in really high demand, so by the time you're listening to this, maybe he works somewhere else. But this would be an example of someone who's gone the graduate degree route, and it's worked out very well for him. And it also allowed him opportunities to work with a lot of other talented people in some of the labs he was working in, as well as getting an opportunity to co-author a book on deep learning. So that's one end of the spectrum of how pursuing a graduate degree can really help you on your path to becoming a data scientist, or in this case, an expert in machine learning. But let's go ahead and take a look at someone on the opposite side of the spectrum, and that would be Adam Gibson, who is actually a college dropout, and yet he is the creator of a library called Deep Learning 4J, which is a deep learning library for Java. He's also the co-founder of a Y Combinator-backed company called SkyMind. So this is someone without any sort of graduate degree. In fact, total college dropout. I believe he only did his first 2 years in undergrad. So again, other opposite end of the spectrum, and he took a much more entrepreneurial type route where he's actually creating his own libraries, has a good portfolio, and is actually able to start his own company. Now, I should mention he dropped out of college to start his company. That doesn't mean I'm giving the advice of everyone drop out of college and start your own machine learning company, but keep in mind it is definitely possible to become a renowned data scientist or entrepreneur without the background of graduate degrees. So again, two ends of the spectrum here. Most people are not going to be at one of these extremes. They're going to be somewhere in the middle. So I just want to give two real life examples of people who have done it one way or the other. So make sure you understand that the topics involved with data science are complex and they're not easy to learn. There's really no wrong or right path to becoming a data scientist, and you should really create your own path on your career journey. Okay, thanks everyone, and I'll see you at the next lecture. Welcome everyone to your first interview question for the probability theory section. Here's your question. Let's imagine that you are given a fair coin. A fair coin meaning that there's the same probability of being heads or tails, or 50% chance of being heads, 50% chance of being tails once you flip it. The question is, on average, how many flips would you need to get two of the same flip in a row? That is, how many times are you going to have to flip it on average to either get two heads in a row or two tails in a row? Just any two of the same. Okay, best of luck. I'll see you at the solutions. Welcome back for question number 4 in the statistics interview section. So this question has a little bit of setup. It first begins with a new medical test for a virus being created. Now, over the entire population, 1% of the population has the virus. With this medical test, 99% of sick people with the virus will test positive. That is, they test positive indicating that they have the virus. So 99% of people who actually have the virus and are sick with it test positive using this new medical test. 99% of healthy individuals test negative for the virus. Now here's the question. If you grabbed a patient not knowing whether or not they had a virus, and you administered this new medical test, and they tested positive, what is the probability that they have the virus, given what you know so far? So you know that overall, 1% of the population has the virus, 99% of sick people with the virus test positive, and 99% of healthy individuals test negative for the virus. So if you took a patient and they happen to test positive, what is the actual probability that they have the virus? This is a very common question, so best of luck, and make sure you understand the solution for it if you weren't able to get it on your first try. I'll see you at the solution.